Willkommen! This is Nick Does Maths. Today we are going to go exploring around the realms of mechanics. That's right, we've let the physicists play for a little bit, but the mathematicians are in, we're going to do it properly. So listen up, we're going to look at some collisions in one dimensions with some elastic balls. As ever, these are big chunky questions. I have terrible handwriting, so let's flash that up on the screen now. Pause, have a quick read. I'll create a synopsize. What? I will sum it up as I go along. I do maths good, not language good. All right, so what do we got? We've got two particles traveling along a straight line on a table. Got A, mass 3m, B, mass 4m. This one will appear in a little bit. A is going at a velocity of 2u, B at a velocity of u. They are going to collide, and they have a coefficient of restitution of e. Our job is to show that the direction of motion is unchanged. So both A and B will keep traveling over to the right-hand side. They'll carry on their merry little way, boop, 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 and they won't hit each other again, for now. Right, so let's do some mechanicsing. What do we know? So first thing we're going to do is we are going to look at conservation of momentum. So how much momentum would we have before the impact? Well, we would have 3m times u from particle A and 4m times u from particle B. And what's going to be going on after the impact? Let's just see what's going on after the impact. Let's call this v. Particle A will be traveling at a velocity of v. uv, let's go for w for particle B. And particle C is just chilling there still. It's still just chilling. It's waiting to explode onto the scene in part B of the question. But we don't need him right now. So, how much momentum do we have after the impact? Particle A will be going at 3 mv. And particle B will have 4 mw of momentum. What's that? Mass times velocity, so kilogram meters per second. What we do see here is we can cancel a few things out, and that will give us 3. That will give us 7u is 3v plus 4w. Now obviously that's not enough. I've got two things I want to figure out in terms of u, v and w, so I need another equation. We're going to use the idea of coefficient of restitution, which tells me that the speed of approach, how fast they close in on each other, times by e is how fast they separate. So e times approach equals speed of separation. So how far are they closing in on each other? This one is going at 2u, B is going at u, so they are approaching at a speed of u, the difference between the two. Do that times e, and that is going to equal to how fast they are moving away from each other. So they are moving away at w minus v. What we have here are some simultaneous equations. So what might we do? What might we do? How about we multiply, which one? Well, I need both of them. I need both of them, don't I? So let's times this one by 3 and add it on. So that will give me 7u plus 3ue is 3v minus 3v. 4w plus 3w is 7w, which will give me w is yada, 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 yada. What have we got? Have I done this correctly? 7w. I've got 3m and 7. Aha! Silly me. Yep, nope, that's okay. So we've got 7 plus 3e lots of u over 7 is w, and I'd set myself up to read that there. Okay. Does that feel okay? No, silly. Let's see how many of you spotted this in the comments already. That was mass times speed, so that should be a 2u, so that's a 6u, so that is a 10u, so that should be a 10u, so that would be a 10. If you spotted that already and you've commented, 10 points to Hufflepuff. Well done. Right, we also need v. I could plug that back in, but I don't wanna, so I'll do the whole thing again. Let's do, if I call this equation 1 and equation 2, let's do equation 1. I'm trying to get v minus 4 times equation 2. So what do I get? I get 10u minus 4ue is equal to 3v minus 4v is 7v. 4w minus 4w is nothing. So what does that give me? It gives me that v is, let's factorize out the u, over 7. Right, this is where we re-engage the brain. I went into full mechanics mode. I saw some stuff I didn't need. I figured them out. Show that the direction of motion is unchanged. Right. So what we want is, we want both of these to be positive. Well, E is between 0 and 1. I mean, technically, it probably could be equal to. I'm not sure we've invented anything that does that yet, but there we go. So that means that both of these, so 10 plus 3 at the smallest is 10. So that will be positive. And at worst, E is 1, and 10 minus 4 is 6. We get 6u over 7. That is always positive. So they are positive because E is between 0 and 1. And if these are both positive, both A is still traveling on to the right and B is traveling on to the right. So we're all good. All right, part B says, all of a sudden, out of nowhere, particle C is there. It's not moving. So only one thing's going to happen here is bosh. Particle B is going to hit it. All right. So let's see what happens after that collision, because we want to show that after B and C collide, A and B will collide. So we need to keep track of what's going on with all of my little particles. So what have we got? Particle A is just still chugging along at V. I'm not going to put that in. That doesn't fill me with joy writing that out an awful lot. I'll do that at the last minute. We need 2 more letters. I've used UVW. What are some good letters? X and Y? Yes. Look at that. Who says mathematicians do not have an imagination? And let's go again. Let's go again. So we're going to go conservation of momentum. Let's have a little look-see at conservation of momentum. How much did we have before the collision? And we are looking at particles B and C. So we have 4mw plus 0. That has no momentum. And after it, we have 4mx and 2my. We could probably simplify that a little bit. Divide everything by m and divide everything by 2, actually. So that's 2w is 2x plus y. Excellent. And again, that's not enough information, but we can use the fact that this is an elastic collision, and the question did tell us at the start that we have the same coefficient of restitution. So, how fast are these two things approaching? Well, they are approaching each other. That's moving at w, that's not moving at all. So it's approaching at w. Times that by e, and we get the speed of separation, which is y take away x. All right. Now, we need to solve these two equations again. I'm not going to solve for x and for y. The only one I'm interested in here is x, all right? Because we want to show that these two are going to hit each other again. So let's find out what x is. Which means that's equation 1, equation 2. We want x, so let's do 2, take away 1. So what do I get? I get w times 2 minus e. I've factorized out the w. Is 3x. So x is w, and actually let's put in what w is. Where did we get w? W is up here. So what is x? X is 10 plus 3e 2 minus e, lots of u, over 21 divided by 3. Whew, we're getting there. We're getting there. And now I want to show that they're going to meet again. So let's make a little bit of space over here. I want to figure out if v is bigger than x. If v is bigger than x, then this will catch it up and they will hit again. The easiest way to compare two numbers in maths is to subtract them and see if it's positive or negative. So let's find out. What did we say v was? We got v was 10 minus 4e lots of u over 7. And x is minus 10 plus 3e, 2 minus e lots of u over 21. And we've now got to play with that. All right. Let's take out a u over 21. I'm going to be a little bit sneaky here for the sake of space. I'm going to take out a u over 21, which gives me a 3, 10 minus 4e, minus 10 plus 3e to minus e. Okay, all right. What can I do with that? Let's make this into a quadratic. U over 21. I'll get a 3e squared. I'll get 6e, get minus 6e. I'll get 10e, so I'm on 4e, minus 12e, that's minus 8e. You can always take the time, write out the lines of working yourselves, feel free. And 30 minus 20 is plus 10. All right, so this is the speed at which they are either approaching or separating. Well, u is positive. Just from all of this, we've taken u as positive, we're going to the right. 21 is positive, so the thing I'm interested in is that bad boy. How can we show that a quadratic is always positive or always negative? Complete the square? No! Yeah, I know, no one enjoys it. No one wants to complete the square. Something you learn at GCSE, and yet, all the way through, I think even university professors don't want to complete the square. So, what does this come out as? U over 21. Oof. So we'll get a 3 lots of e. That's an 8/3, so we'll go 4/3 squared. I want 10, that would be 16 over 9, 16 over 3. I want to get to 30 over 3, so that's plus 14 over 3. The important thing there, of course, is that this whole thing here, right, that is absolutely positive. All right, 14 over 3 is bigger than 0. Something squared is positive. We're adding them together. So all of this is always positive. That means that v is always, v is bigger than x. Therefore, they will collide. Bosh! Woo! All the real maths we've done here is a bit of simultaneous equations. It's just about keeping track of your algebra and getting to the correct conclusion and knowing what it is that you're trying to figure out. I hope you found that interesting. Tell me what you think over in the comments. Don't forget, click, like and subscribe. Hit the bell to find out more maths as it comes out. Every other day or so, we're producing videos weekly. And there we go. I'll catch you next time.